So on this particular foldable, we're going to do all of them basically, you're going to be doing some sort of taking a power, raising it to a power to a product. That means if you have, two things inside of here, and then power to a quotient. Okay, so that means like if it looks like a fraction, what do you do if you have a power on the outside? All right. So like I just stated here, since there's parentheses, there's a power here and a power here, we're going to be multiplying the powers together. All right, so this is what you want to write on your foldable: to raise a power to a power, keep the base, and multiply the exponents. Okay, so that's the first word you should fill in for your foldable. Okay, multiply the exponents. So then we got some concrete examples, okay, using some actual numbers. So our base is x, and we're going to multiply 4 times 3. We get x to the 12th, okay? 7 times 5, we get 35. Okay, so we're raising a power to another power. We multiply the exponents. So now this is a power to a product. So if it's a power to a product, so that means you have more than one term inside of here, then you're going to raise each one to the power or multiply. Okay, so let's look at some examples. So it says to raise a product to a power, you raise both factors. Factors are numbers that we multiply together to the power, and you multiply the exponents again. Okay, so both factors have to be raised by multiplying. So here we go. So see how you have an F and a G? So it's almost like distributive property. That power on the outside, you're going to have to multiply by the F, that gives you 21, and then by the G, and that gives you 35. All right. Now, what if that product inside also has like your coefficient 4 here? 4 also has to be raised, or think of this, because every number in every variable has an exponent. When you don't see it, there's an invisible 1 here. So that's like 4 to the first, R to the second, S to the ninth. So all of these have to be multiplied by the 3 that's on the outside, by that power that's on the outside, even the 4 to the first power. So 1 times 3 is what? 3. So 4 to the third power is 64. So if you do 4 times 4 times 4, or just raise 4 to the third power on your calculator, you get 64. Okay, please don't multiply 4 times 3. Okay, because that's going to give you 12, and that's not the right answer. You're raising the exponent, the power, to the power. So that gives you 4 to the third power, 64. 2 times 3 is 6, and 9 times 3 is 27. Okay, so sometimes you have more than 2 factors in here. You could have 3 or more. So we're going to do the same thing here. That 2 has an exponent of 1. So that has to be raised to the 1 times 5, 5 times 4, and 5 times 3. So 2 to the 5th power, you put it on your calculator, you get 32. And then you get e to the 20th and f to the 15th. Okay, any questions so far? Okay. All right, moving on down to the next one. So here, and you got to be very careful when there's a negative, okay, because since this is in parentheses, you also put that -5 in parentheses. So if you were to expand this out, it would be a -5 here, raised to the second power. Now, it's important to put those parentheses around it because it does have parentheses. Why? Because this is a different answer. Okay? This equals positive 25. When you put it on a calculator, this equals negative 25, which is correct. Without the parentheses, you would then only be raising the 5 to the second power and not the negative. So that's why it's very important. If one of the factors is negative, please make sure you put it in parentheses. Okay, always, always, always. So then I'm going to end up with this. 25, because I'm raising the negative as well, is in parentheses. And then multiply 6 times 2, multiply 1 times 2, and 8 times 2. All right, last one is called, what if you have like a fraction? We call this the power to a quotient. So again, you're still distributing, or multiplying that power on the inside times the power on the outside. So here it says to raise a quotient to a power, you raise the denominator. That means you do your denominator and your numerator, both numerator and denominator. You have to multiply those exponents. Okay, top and bottom. So here we go. So again, keep in mind, every variable and every number has an exponent. So these are like ones. Okay? Every number, every variable has an exponent. So when you actually multiply that exponent that's on the outside, 1 times 6 is 6. 1 times 6 is 6. Okay? So what if there's another factor in there? That also has to be raised or multiplied. So these are ones again. Okay, so we're going to raise 7 to the second power because 1 times 2 is 2. So here's our final answer, 49, B to the second, and C to the second. Okay. So I'm going to add a couple for you. Okay, so you could add this. So what if we just had a fraction? Let's say 4/5 to the second power. Okay, add this to your foldable, please. So again, every number has an exponent. The invisible exponent is 1. So you're going to say 4 to the second. Same thing down here. 5 to the second. And then you'll just say 16 over 25. Okay. And that would be your answer. If you could reduce it, you would. But in this case, we cannot reduce any further. Okay. And that is your lesson on the power to a power. All right, so we did the class notes for the foldable. Now for classwork, based on your calendar, you're going to be doing page 4. And then your homework tonight, just follow what you see on your calendar. Okay, so classwork page 4. And then if you have time, you can work on your homework. Some of you need to work on making sure that you have your midterm review completed, because I'm going to check that next class, and that is going to be for points. All right, guys.